Welcome back to Team Rocket, and in today's video we will be looking back at the past 2 weeks of the class, and me and Oliver will be explaining the major breakthrough moments. The first thing our team did on week 3 was to brainstorm some rocket designs.
Oliver and I currently looking at the best parameters, both for like rocket height versus the diameter and the best like fin shape. And I mean, theoretically the best fin shape is supposed to be elliptical for some reason, but in practice it's not that, so we're trying to figure out what we're going to do for the shape of the fin, shape of the cone, shape of the other things. Shape of the cone, apparently it's a parabolic shape, and that's from aerospaceweb.org.
Once we found the rocket design, we then decided to start with a small rocket, and then if everything would go well, we would upscale.
Alright, so we're figuring out we're going to start building for the small one for weight restriction and simplicity, and then we'll upscale if everything goes really good. The advantage of going upscale is that we can fit maybe a gimbal in there, but we're still not sure if we want to go into that kind of complexity. In terms of length versus diameter, we found that the Goldilocks zone is between 10 and 15 for one, so 15 times about longer than it is wide. We're starting to think about the shape of fins. The best is probably elliptical in theory, but in practice it looks like it's often trapezoidal. We're going to look at airfoil, what is that going to look like, and we'll start thinking of mounting system both for the top and for the fins.
In this clip, Julian is giving one of the many ideas we had to mount the fins of the rocket. We decided to use some L brackets, and in the background we can see me and Alexandre creating the fins.
For most of the testing process, we're probably going to use L brackets that are going to be like on the body of the rocket, so like this, with an L bracket that's going to be supporting the fins that we're making right now. And that's going to allow us for the majority of the testing process to interchange the fins, so to make multiple models, test them in the wind chamber, and we can just put tape over the screws so it doesn't have too much drag. And when the time is going to come to pick the final ones, we can probably like 3D print them or like make them very nice, and then just do some sort of slot so that they insert into the rocket, so there's less drag. We've tried two methods for fixating the fins. One of them involves L brackets and screws. The screws would obviously be shorter because we don't have the right ones now. It's relatively long, but I thought it would be more stable. Turns out it's not. Hot gluing the fin looks not only the same amount of precision, if not maybe more, because piercing holes and then screwing stuff with the weird shaped L bracket is maybe not the best for angle. I think we'll be sticking to making multiple of these tubes with hot glued fins for now.
In the next video, we found out that trapezoid fin shapes and elliptical fin shapes are the best for the rocket.
It's one body with fins. It's going to be perfect for testing. This is not what we intend to use for the actual plane, but for testing it'll do. Yeah. Elliptical shapes and trapezoidal shapes, just to test both in the wind tunnel that's being built.
Now I'm working on the fins, so they're full of holes. So I'm trying to put tape all over it. So I took a big thing of tape and I just like cut it at regular interval, so that the tape can go over itself and so it doesn't do bubbles.
In the next couple of videos, me, Oliver, and Antoine tried to find a way to try and mount the electronics on one small board so we can fit it inside of the rocket and attach it to the nose cone. Here we are trying to find a way to mount all our electronics on one board or one piece that will be able to fit inside of the cone and put on top of the rocket. So right here, we created our first prototype to try and secure and mount all the electronics. So we made this little gimbal and we put little holes so we can attach it on the 3D printed piece. We're also going to make a 3D printed board. Jeremy from the future here. As I'm editing the video, I realized that I said we're going to make a 3D printed board. In the next part of the video on week 4, we're going to see that I did make that 3D printed board, but it didn't really fit inside of the rocket because the measurements weren't really good. So on week 6 to 8, I'll be making a new version, and we might even change the design of it. We might make it a circular, somehow stack the electronics on top so we can just slide it in, slide it out. Alright, back to the video. Here, we're not going to keep this, it's just a prototype, and then it's going to go inside the rocket. We're also going to find a way to try and secure this so it doesn't move back and forth. We finally found the solution from our problem we had on the last video. We decided to modify one of these caps that went on the tubes, and we used the X-Acto to cut off the edges, and we put this the little cap inside to add like a little platform. So now we can add this our little
Sensor platform.
our sensor platform on there. While we were prototyping the electronic board, Oliver had designed a nose cone earlier, and we decided to print it out on the 3D printers at the Makerspace. Unfortunately, the nose cone that we printed at the Makerspace was too small for the diameter of the cylinder. We then attached the nose cone to our prototype rocket, and at the end of the period, we threw it a couple times to see if it would be stable during a free throw.
So I've just started 3D modeling the sensor board based on the prototype that we built in class. So this is what I've got right now. And I'll add a battery slot and some other details for the model to get the right measurements.
Later that night, I decided to take Oliver's 3D model of our new sensor board, and I decided to print it overnight. Here's the completed electronic board.
So here is the first 3D model that Jeremy printed for the sensor board. So it looks pretty good, but I made a few mistakes about the dimensions for the multiple sensors and the battery. For example, the battery is a bit too big for the box that I modeled, and the other sensors, this one works fine, but the Arduino I missed a single dimension, which is the distance between the pins, over here. So I made the modifications on Blender, and this is the new model here. There's not much that changed, but a lot of dimensions changed. We're going to reprint that probably tomorrow when Jeremy finishes to print the tip of the rocket.
On week 4, our two main goals were to continue designing the rocket, and by the end of the period, we needed to put the rocket in the wind tunnel so we can then have some values so we can measure the drag coefficient. In this video, Alexandre is designing a new pair of fins so we can laser cut them. By laser cutting them, the fins would be more sturdier.
Hi, so right now, this was our first model of fin, but we cannot slot it by like, we want to like put this inside of the rocket so it sticks better, but now I'm trying to like change the place of this to make it stronger.
Antoine is now modeling a way to attach our electronic board to the rocket, and we're doing a couple of prototypes. In the last video, me and Antoine were modeling a new way to attach the sensor board inside of the cone because we had printed a new cone before the class, and then we made the cone too big, and we went to sand it down but destroyed the plastic because sanding it down heated the plastic up. We also went through 3 different iterations of the sensor board, except you can see the first one that we made was the first black one. We then made the one in the middle with the battery pack on the same horizontal axis, and then we had put the 2 sensors, the one with the SD card on the front and the Arduino in the front. But then we realized that the battery doesn't fit in the cylinder, so we decided to do the third one, but the third one had a failed print. The third one was basically supposed to have the battery pack vertically and not horizontally, so the battery could fit inside the cylinder. We then realized that we should probably do a new model of this sensor board, and like I said at the beginning of the video on the week 3, where I interrupted the video, I said that we might do a stackable version of this. Here was the design of the new nose cone we did, except it got destroyed by sanding it.
So at this point, we were ready to start recording some data in the wind tunnel with our rockets. Our blue rocket wasn't quite ready when we used the tunnel with the smoke, but we did use it with the leaf blower. For the other one, with the translucent tip, it worked on both tries. Here with Rocket 1, as you can see, we were in the wind tunnel with the smoke, so the first wind tunnel that we used, And as you can see, the frame of the video is pretty slow because we use a slow-mo cam, which I had to modify it to go a little bit faster because of the LED. We were creating a strobe light on the camera effect. So basically, we can observe here that the wind doesn't have that much of an effect since it's too slow to be catched even with a slow-mo cam. Well, you can observe it by the tags at the end of the wings. On our second try with the same rocket, we can see that the wind is going a little bit faster. That's why we see the flaps at the end of the wings move a little bit more. These stickers shows us the turbulence at the end of the rocket, which will probably be a good indicator of the drag coefficient that we are looking for this week. We then headed outside to put the rocket against higher winds. This test with the leaf blower displayed some clearer results, especially with the use of the scale and the mass, where we were able to see just how much the wind was pushing against the rocket. The second try was a little bit more stable, even though the first one wasn't that bad. With this data, we were then able to find the drag caused by the rocket. In that example, the one with the blue tip. Here on the screen, you can see that the mass is definitely moving. That's because of the motion of the rocket. So this was the end of our experimentation with the wind tunnels. After that, we had Julian working hard at welding our sensor temporary in place, so now we can use them in the next experiment. The welding is displayed in this 30-second time lapse. So that wraps it up. Thank you for watching our progress, and we'll catch each other back in 2 weeks for our next update.